So let us begin strengthening mechanism. In strengthening mechanism, the first type is alloying. Okay, what is mean by alloying? See, generally we know that. Okay, I have said before also, and I am saying now also. If you take any material and if you mix with another material, that is, if you form an alloy, then the material which is a pure material and an alloy. So alloy is going to be going to have a very good property compared to the pure metal. For example, take gold. Okay, so if you take a pure gold, you won't be able to form an ornament because it won't be flexible enough, it won't be ductile enough for forming for forming the ornament. But if I mix it with copper, not a huge amount of copper, but small amount of copper, a small impurity added in order to make it into an alloy, then I can make it into ornament. Different shapes can be made, right? So alloys are generally superior in their property. Their strength will also be superior compared to the pure metals, right? So in order to increase the strength, we can add alloy, that is, we can add some impurity. But if you add impurity, there are two ways in which the impurity is going to occupy the host atom. For example, consider gold and copper itself. Gold is the host and copper is the impurity. So if I add copper into the gold, that is in the host, the copper can situate, that is, the impurity can occupy two different types of places. Okay, one is going to be interstitial site. Okay, the impurity can occupy interstitial site, or the impurity can occupy substitutional site. Okay, so first let us talk about interstitial site. So see here, suppose if I take, this is my host atom. Okay, if I take, these are my host atoms. The small space which is present here between these host atoms, that is nothing but interstitial space. We have already discussed it. And if you consider this interstitial space compared to almost all the impurity atoms which you are going to add, any atom you take, any impurity atom you take, these interstitial space are going to be comparatively small. Okay, if I try to include, actually this is how, okay, this is how, this much big impurity atom. So this is my impurity atom, and if I try to include that impurity atom in this small space, what that impurity atom is going to do? That impurity atom is going to apply a compressive force here. Okay, it's going to apply some compressive force, or I could say that it's a compressive strength field. Okay, a compressive force or a field is developed which is going to offer compression in all the sides. So compressive strength field. I will give an example. Just consider that you are standing in a queue. Okay, you are standing in one queue for buying some ticket. Okay, you are standing, just consider that you are a lean guy, okay, thin guy, and you are standing in a queue, and suddenly you want to vacate your place and your friend has to occupy your place. Okay, just because you are feeling your leg was paining, so you are not able to stand for more time. So you are asking your friend to occupy your place. You are standing in a long queue. Okay, so what you planned was, like, initially you will stand, and then after that you will leave, and then your friend will stand, and after that he will leave, you will stand. So alternatively you will vary it so that you won't feel tired, you won't feel fatigue. So as you are feeling tired, you left, and this place will be occupied by your friend. Just imagine that your friend was a little bit fattier. Okay, he is having somewhat more weight. So initially the space which you are accommodating is very small, but now when he comes and tries to accommodate that place, it's going to push, that is, he is going to push the atom, that is, he is going to push the person who is present in front, and he is going to push the person who is present in back also. The same situation here also. This impurity atom will try to push this host atom this side, and this atom this side, this atom this side, this atom this side, because it has to occupy the small space which it is available. So it will create some compressive strength field or a compressive force. The compressive force will be acted by impurity on the host atoms. That is the first thing. Right. So why it is happening? Because impure atoms are generally larger in size compared to the interstitial site. Okay. Now, coming to substitutional site. See, substitutional means what? Suppose if I take, these are my host. Okay, these are my host atoms. Okay, one atom leaves its space. Okay, one atom leaves its space, and another impurity comes and occupy in this space. okay, another impurity comes and occupying the space. That is what substitutional site means. Okay, it's just substituting the host atom. There are two different possibilities in substitutional. Suppose, let us consider that this is the atom which is leaving, okay, host atom which is leaving, and a very small impurity atom is occupying this place. You take an example of you are placing bricks, okay, so one brick over the other brick over the other brick over the other brick. Just consider one brick, another brick, another brick, one brick, another brick, another brick, one brick, another brick, another brick. So there are 3 columns of bricks. Suddenly you are removing one brick from the center and you are including some small stone, okay, or keeping some small stone here. What will happen? All this will fall, right? All this brick will fall towards this. So here there is going to be development of a tensile strength, okay, or tensile force or tensile strength field. So here there will be a strength field developed, but here this is going to be tensile strength field. Clear? Now what if the same situation happens? Same space was there, but consider that the impurity was very larger. Okay, the impurity is very larger. What will happen? The impurity is very larger. Obviously, the impurity is going to offer a compressive stress. Okay, the impurity is trying to compress the atoms which is present, which is surrounding it. Something which is similar to this. Okay, the example of a person standing in a queue. Okay, so again here there will be development of compressive strength field. So why I explained all these things? What is the reason for explaining all these things? Very simple, to link it with the dislocation. See, all this, either it is a tensile strength field or a compressive strength field, either it is due to interstitial site or substitutional site, that is, the impurities occupying an interstitial site or substitutional site. All these things are going to obstruct the motion of dislocation. When the dislocation tries to move, these strength fields are going to obstruct the motion of dislocation. So these things will act as an obstacle. So hence the dislocation is not going to move that easily. So strength of the material automatically increases. So that is how alloying is increasing the strength of the material. So by occupying the interstitial space or substitutional space, and by creating either a tensile strength field or compressive strength field, those strength fields are opposing the motion of a dislocation, and that results in increase in the strength. Okay, so this is the first method by which we can increase the strength, that is by alloying.